Good morning, everyone. My name is James, and today I'd like to chat to you a bit about Formula One. I've been watching Formula One since the beginning of the 2021 season, and ever since then, I've just been absolutely hooked on the sport. Obviously, the appeal of watching fast cars go around the track is always cool, but the technology and data side of it is really interesting to me too. So that's what I want to chat about today. So Formula One is said to be the pinnacle of motorsport, and I would agree, but the role data plays in that cannot be overlooked. Advancements made in Formula One haven't only made the sport better, but it's also improved the world around it. In this presentation, I would like to cover some of the automotive and data technologies developed in Formula One and how it has impacted the rest of the world. So many automotive technologies developed in Formula One have now made their way to road cars. And some examples of these are carbon fiber, paddle shifters, and active suspension. So let's chat a bit about them. So while carbon fiber was first developed in 1860, McLaren made history by implementing the first carbon fiber chassis in their 1981 Formula One car. You can see the picture on the left there is the first carbon fiber chassis they developed, and on the right is the car in its entirety. So carbon fiber was used in smaller parts before this, but McLaren made a significant leap forward by implementing the carbon fiber on a larger scale, like this. And the advantage the carbon fiber chassis gave them was how lightweight it is while still maintaining its structural integrity. And yeah, they found a lot of success with this car. I mean, with this technology, and it has now also been implemented into road cars. On the left, you can see an example of a McLaren chassis and a Lamborghini on the right. Next, let's talk about paddle shifters. So Ferrari were the first to implement paddle shifters in the F1 cars in 1989. And what paddle shifters are basically these buttons on the back of the steering wheel, which allows the drivers to quickly and efficiently change gears. And the other advantage of these is that it allows the driver to quickly change gears, but also puts less strain on the components of the car. On the left, you can see the steering wheel that Ferrari implemented the paddle shifters on first in 1989. And here's a more modern steering wheel. And you can see that they've implemented more shifters on the rear of the steering wheel. And the drivers can map these to whatever they want. So like the clutch, for example. And the innovation was so groundbreaking that only 8 years after it was implemented in Formula One did they implement it in road cars. And it just enhanced the consumer experience, I'd say. Next, let's talk about active suspension. So active suspension is one of the most prominent features developed in Formula One that has now been implemented in road cars. And what active suspension does, it essentially allows the chassis to adapt to the track to improve traction and handling. And Williams were the first to implement it in their 1992 car. And since implementing it, they actually went on to win the next 3 constructors championships in a row. And that's mostly thanks to the active suspension they developed. So now let's take a look at the data side of Formula One. Formula One really is a data-driven sport, as the data enables the car's development and improvement. So I want to dive into how data is collected in Formula One and how it is handled. Just to give you an idea of the scale of the data that's in Formula One, each car has around 300 sensors, and these sensors generate over 1.1 million data points per second, which is obviously a massive amount of data that needs to be handled. So naturally, Formula One is going to need a large, well-developed cloud computing software to handle all of this data. I'm going to show you 3 images, and I want you to try guess who Formula One decided to partner with for this. Here's 1, 2. So if you haven't guessed by now, Formula One chose AWS as their technology provider. And this happened back in 2018. And since then, they've developed 22 different data-driven Formula One insights that are now available to us. Now, let's look at how the data is collected. As I mentioned before, there are around 300 sensors on each Formula One car, and each of them generates over 1.1 million data points per second per car. So I just wanted to say that stat again, because I just want everyone to really understand how much data is really in Formula One. And these sensors collect valuable information for the Formula One teams, as seen on the diagram there. And not only do the teams use this data, but also the regulators do as well. Because Formula One is quite tightly regulated, and things like fuel usage is tightly monitored by the FIA, who are the regulators. And often teams will get disqualified if they don't meet these requirements. So it's very important for them to be monitored. So on top of all this data generated from the cars, the tracks also produce a lot of data that the teams will use. And these will include things like the car's timings, telemetry, and other factors like the weather. So now, how's all of this data handled? Well, basically, all the aforementioned data is collected at the Event Technical Center, which is then sent to the Remote Technical Center in the UK. After which it goes through the AWS cloud and processed, and the information is then sent back through the chain to all the teams and to the broadcast that we watch. Now the next question is, how do the F1 teams gather and use the data? So the teams have a variety of run plans that they do throughout the weekend. In the 3 practice sessions leading up to the competitive sessions of qualifying in the race. That's on a normal weekend at least. They have implemented a new format, but it still stands that they collect the data in the practice sessions to prepare for the competitive sessions. And here's an example of some extra sensors the teams can put on their cars. So these are called aero rakes, and what these do essentially is measure the airflow that goes over the car. And the teams will use this for things like assessing how accurate their simulations were in their development process, and just ensuring that the things they're doing match align with real life. Teams also use the data to compare the driver telemetries between their 2 drivers and the rest of the drivers on the grid. The telemetry of all the drivers is available to all the teams, and this can be beneficial for the slower drivers to see what the faster drivers are doing differently, and to help them find some performance that way. Teams will even analyze the data of their rival teams to potentially come up with counter strategies for the race. Okay, now that we've covered how the pros use the data, let's look at how us casuals see it. F1 as I mentioned before, F1 and AWS have worked together to create 22 different data F1 insights, and I want to show you a few of them. Show you some examples of a few of them. So these F1 insights are broken down into 3 categories: race strategy, competitor analysis, and car performance. So here's some examples of the race strategy graphics. So this is called the battle forecast, and essentially what this does is it looks at the data from the 2 drivers they're comparing to see in how many laps the chasing car will catch up to the car ahead, and they even predict an overtake difficulty. So that's one example. Another one is the pit strategy battle, and this shows the predicted gap between the car who pitted first, in this case Verstappen, and the car behind who's attempting to undercut, which is Hamilton in this case. And they even give a percentage chance that Hamilton will overtake Verstappen from the undercut. Another new insight they've developed recently, I think this was implemented last year, was it's called the alternative strategy. And essentially, with this, they look at a decision that was made during the race, and then they simulate what could have been if they made a different decision at that time. So in this example here, if Carlos Sainz had pitted 3 laps earlier, they estimate he would have gained 1 place in the race. So I really like to see these sort of graphics. I think it gives nice information about the race. However, some Formula One fans don't agree with being shown these graphics because they feel that maybe it takes away from the suspense and the anticipation of the race and the overtakes. Now let's look at some comparator analysis insights. For example, the close to the wall. With this one, they have set up high-tech cameras around hotspots of the track to measure how close to the wall a car will get. And in this case, you can see Verstappen got 1.2 centimeters to the wall, which is quite insane. And it really shows you how tight Formula One is and how the driver's always trying to push the limits of the track. Another example is the start analysis, where they measure the reaction time between 2 drivers. And this happens at the start of the race when the lights go out and the drivers start to move off their line. And to go with this stat, they also show the driver's time it took them to get from 0 to 200 kilometers per hour. And you can see in this example, even though Sainz had a better reaction time, Norris was able to get to 200 kilometers an hour quicker. And that's, I don't know, to me, that's quite an interesting stat to see. And I'm sure that it's very useful to the teams as well. Next, let's look at the pit lane performance. So with this one, they compare the time in the pit lane between 2 drivers, looking at entry and exit times, as well as the time spent in the pit lane. And that can be heavily influenced by the pit crew. So it really shows how important that is too. Now, let's look at the corner analysis. This is also quite a useful stat for the teams, as it can show just how differently drivers can take the same corner. In this example, you can see Hamilton is slightly faster than Leclerc because he brakes later into the turn and he's able to get around the corner quicker. And I find that interesting, and definitely the F1 teams do as well. And then finally, another stat they have, another insight they've developed is called the projected knockout time. And essentially in qualifying, how it works is that in the first qualifying session, the fastest 15 drivers will progress to the next session, and the slowest 5 will be knocked out. And by looking at data from the practice sessions, the AWS machine learning was able to predict a knockout time for the bottom 5 teams. And from what I've seen and from my experiences, it's actually quite accurate. So it's quite impressive to me. So I'm a big fan of these F1 insights, and I really appreciate that they can share it with us. And Formula One is exciting to me because it's always pushing the limits of technology, and I just can't wait to see what technologies are developed in the future. And I will definitely continue to watch Formula One for a long time. Thank you.